Okay, let's try to put this into context. In the last lesson I went through a half adder and a full adder, and then I did some testing with both the half adder and the full adder and the different bits they could take. Now this really isn't anything that you should be expected to produce or actually produce yourself. This is way too complex. I'm showing you this because this was an extension task, a half adder, when we were doing logic, and in context we can reproduce this on a computer in Python or in any language that we like, really. So there's a direct link between the logic diagrams and programming, which is why I am showing it to you. However, the half adder and the full adder only work with single bits, so just columns, each and every column. What I would like to do really is have a program which added two binary numbers together, and that's what I'm going to show you in this particular video. Although you won't be expected to reproduce any of the information or programming from this video, I still think it's a good idea to try to follow the understanding, follow the methods, have a good understanding of the methods and how it's written, and also it's going to improve your binary and your understanding of binary, and it's all going to be useful for the exam, although not questioned in the exam. So I've just commented out the half adder and the full adder, and I'm going to leave the result as it is. And what I'm going to do is now create a program which is going to add two binary numbers together. So I'm going to want a function to do that. So the function that I'm going to really have, so I'm going to use result again. Let's call it binary add. You can think of any name that you want, and it's going to take two numbers, A and B, and it's going to add those two numbers together, and it's going to print the result out. The answer is going to be in result. I haven't got a function for binary add yet, so part of my design is thinking logically about what I could do. So let's create it. Def binary add, and it's going to take two values, an A and a B. Both of those are going to be binary numbers, and it's going to return, let's just put R for result. Now if I save this and try to run the program, I would actually get an error, but let's just do that just to show. So let's run it, and the error is going to be because I haven't really, there we go, name A is not defined. I haven't initialized any of my variables. I really need to initialize them before I use them, and that's what it's saying here. It's got to this line and it's saying I don't know what A is because I haven't set it. So let me set A equal to, let's use an 8-bit binary number as a string. 1, 2, 3, 4. What I'm going to do here is number 5, 0, 1, 0, 1, and I'm going to do B as well. So I'm going to add 5 and 10 together, which should give me 15, which would be 4 ones on the end with 4 zeros at the beginning. So 1, 0, 1, 0. So that's 5 and 10, that will give me 15. It's still not going to work, so I'm going to save it because I haven't defined R. And there we go. So I've got a crash. R is not defined because I'm trying to return something that I never declared. So if I just change that to R equals an empty, now there is no way of representing a binary number in any language really other than as a string. So the result is going to be a string and the inputs are going to be string, and we're going to work on strings. So this time when I run the program, it'll be okay, it won't do anything. There you go. But it won't crash. So that's kind of building up. I'm going to look at defensive design and defensive programming as well, particularly in the next video. But I don't want these videos to get too long, otherwise they're going to bore you. I'm just going to start at this one with a couple of lines of code, then stop and finish off this particular program. So let's think about it. I've got two 8-bit numbers. That's what I'm interested in, adding two 8-bit numbers. And the way I'm going to add them is I'm going to start on the least significant bit and add those two together. Now the least significant bit is different to all the rest of them because that's the only one that needs a half adder. There is no carry in on that one. Every other column after that has a carry underneath. So this would require a full adder, a full adder, a full adder. So if I've got 8 bits, I'm going to be doing 1 half adder and then 7 full adders. So that's quite a challenge. So I need a loop to go over things. So I'm going to say for index in range 8. I've used 8 because there are 8 bits, so it's going to count from 0 to 7. And I can see this if I just do print index. So again, save and run my program, and this should print out. There you go, 0 to 7. However, 0 is the first one I come along. In other words, it's the most significant bit, and 7 is the least significant bit. I actually want it backwards. I want it to go from 7 down to 0 because I am using a string. So this in position 0 in my string is the most significant bit, but position 0 really should be the least significant bit. So I need to work backwards through this string, start at this end and work my way there. So that needs to be my 0 least significant bit, and at the moment on my count that is the 8th or the 7th. So if I got the index of that, I'd be working with these. So I need to sort of upside down it. So actually I need a little trick. I'm going to say that the string index, that is the index I'm going to use on the string, is 7. That was the biggest number I had. I had 0 to 7, and I'm going to say minus the index, and that will give me the values backwards. So let's see that happen in real time. Oops, I should have said print. There's index. What I didn't do was print string index. That's what I really needed to do. And run that, and I should get the numbers in a backwards order. 7 down to 0. Now that's great. So the first value I get is the value 7, which on my string index would be the 7th one along, or the 8th one. Index 7, so it's 0, 1, 2, 3, 4, 5, 6, 7. I am now looking at that as my first item in my loop. So that's the first part of the program. I'm going to stop the video now. If you need to type that in, and in the next video we will complete this binary addition.